Now we're going to talk about a special type of method, and that is a constructor. A constructor can be thought of very simply as a method that is only called when an object is created from a class. You can have multiple constructors as long as they take different parameters. You can always tell a constructor by one rule. A constructor will always be named after the class that it is contained in. Below I have, in the far left corner, a class of car. It has three variables: name, wheels, and weight. Then I have a constructor which is named after the class. A constructor is simply a method named after the class it is in. In this case, it is named car. A constructor is the initializer of a class. When a class is created, like on the right here, new car, the constructor is run. A constructor is commonly used to initialize the state of your object. In my initializer here, I am simply making name a blank string, setting the wheels to 2, and setting the weight to 1000. So I'm basically giving each value a nice default value. Now, by default, a constructor is created in every Java class, even if you don't create a constructor. This is so you can create an object without writing a constructor method. So if you got rid of this public car method, you could still call it, and then a blank constructor would be initialized for you. This constructor that's created for you does not do anything, but it's there so you can call it and create your new object. So whenever I call new car and you see these parentheses, anytime you see opening and closing parentheses, you're calling a method. And in this case, you're calling the constructor method that I wrote right here. And that's initializing all the variables. You could also call other methods that you've written inside the car class if you choose to do so. Now I said you can also write multiple constructors for different initializations. Now I have class car again, very similar as we saw on the last slide, but I also have two constructors. I have the above one we already saw, and the second one, which takes two variables, a string of n and int w, and then it initializes the name to n and the wheels to w. So whatever parameters I give this constructor that I call, I can then see that the name gets set and the wheels get set to whatever I pass in. Let's flip to the code to actually show this in action. Now you can see here I have the same constructors. I have the basic one and then the one with parameters. And now let's go to our hello file, which has our main method to actually run this code. When I call a new object with car C, I'm calling the basic constructor, which initializes my name to a blank string, as you saw. But let's make another car object and call it C2, and we'll call a new car. But instead of using the basic constructor, let's use the other constructor, which is to give it a string of Ford, and then the number of wheels, which is 4. So now I'm using my second constructor, and that's going to print out a whole different slew of things. So when I do c2 print dot, name, well, that's private. I can't print out that. I'll print out the wheels. When I run this code, I will see that the wheels are now 4 instead of 2. And you know what I can also do? I can copy this and we can print out C and C2's dot wheels, and we can see that they're different. C's wheels are 2 and C2's wheels are 4 because the default initializer initializes the number of wheels to 2. That's how you can use constructors. So we can add parameters to our constructors, which we then add to when we're creating a new object. We just fit them inside the parentheses. And then we can add default constructors that don't take any parameters. And we could add as many constructors as we want. We could add a third one which initializes the weight as well in our parameters. So that's pretty cool, and that's the power of constructors.